Hello, welcome to this week's show, Math Matters. Why do I need to know this? Where we try to show you some of the math that you're learning in these entry-level math courses and how they kind of apply to the real world. I've got some neat stuff to show you today. I'm actually kind of giddy about the stuff I'm going to show you today because I think it's really kind of slick. And let's get going. The first thing I want to show you today is an application of surface area and how it applies to home improvement projects, and particularly painting home improvement projects. There's all kinds of things that where the concept of area is kind of useful, wallpapering for example, but it takes a little more knowledge than just the area of the wall, because there's other issues involved, such as is there a design on the wallpaper and these kind of things, and so do you have to worry about losing part of your wallpaper at the top and the bottom of the wall and things like this, or after you cut a section off you can't use it somewhere else. So area is a thing to worry about when we're doing that, but it's not the only thing to worry about. However, if we talk about paint is one of these things I can kind of smear around, and there's very little waste involved. There's a little bit when you think about rinsing out your brushes or your rollers, these kind of things. You do end up wasting a little bit of paint, but not a ton. So really, when we're painting, an area measure is pretty useful to us. And I'm just basing this on some gallons of paint that I had out in my garage. A gallon will cover between 250 to 400 square feet of material, depending on the coarseness of the surface. And if it's very coarse, it will take probably closer to 250. And we also have to take into account that a second coat is usually going to be needed on newer surfaces. Now, what I want to look at today is a case where, suppose you've built a storage shed, it's covered in exterior paneling that you intend to paint. Now, exterior paneling is very rough, so I'm going to go with that 250 number in this, and you may even find that we would need to scale that down a little bit, but I'm going to work on the premise that I can cover 250 square feet of this exterior paneling with paint. And really, I got a nice picture of my shed here. I don't need to worry about the roof, so I'm going to actually take the roof off of this. Let's go back and take a look at things. I'll take the roof off. That's aluminum roofing. I'm not going to worry about that. And I'll give you the dimensions of all the different things that we're looking at. The question that I would like to try to answer with you guys is, how many gallons of paint do I need to buy in order to coat this twice, in order to put two coats on the exterior paneling of this shed? And it's an important question. I mean, you can always go back and buy more paint, but if you're doing this as a contractor or something like that, you may want to, probably have to give an estimate. So you want to know up front, how much paint do I need, these kind of things, or how much do I need to pay for. All right, let's take this house apart and do things a piece at a time. There are actually here four flat surfaces that I need to apply paint to. I'm only painting the outside, I should say. So, but I'm going to take it apart and look at it a piece at a time. This is the back wall, and the whole shed is 12 by 16. The base of this short wall is 12, and it goes up 8 feet. Let me kind of get my pointer going up to here, and then it's 12 feet up to that point. But let me just deal with this 12 by 8 business. That's a rectangle. It doesn't look like a rectangle there because there's dimension involved, but it's a flat. If I looked at it flat, straight on, that's a rectangle. And area of a rectangle is length times width, so that is 12 times 8. And then I've got this triangle on top here that I want to deal with. If the whole thing is 12 feet, I've accounted for 8 of those, so it's 4 feet up to there. And area of a triangle is 1/2 base times height, so this is 1/2. The base is 12, the height here is 4, and so that works out to be 120 square feet on the back wall. And I'm just painting actually the other surface on the back side of this wall would be the one I'm painting. Now if we look at the front wall, that's the same, except that it has a door. A 3 by 7 opening for a door, so we're going to subtract that area. That's 7 times 321, and so the front wall then is 91 square feet. So that's got the front, got the back. Now let's move on to the sides. The right-hand side is simply a rectangle. There's no window there. It's a 16 by 8, so that is 128 square feet if I've done my calculations correctly there. And then I've got the opposite wall. That would also be 128. And then, but I've got that window there, which is a rectangle, 3 times 3.5. So if I've done all my arithmetic correctly, that works out to 117.5 square feet. Now, what I want to do is add all that up, get the total area. So this is my original kind of construction. I add all those things up, I get 464.5 square feet total. And then I want to do 2 coats. So I'll double that, and that comes up then to 929 square feet. And then I need to do something that I did a few weeks ago, and that is convert that into gallons. So I'm drawing an equivalence here between 1 gallon and 250 square feet. I multiply by 1. I get the square feet to cancel out. And so it works out that it's about 3.7 gallons of paint to cover that. So you'd probably end up making a purchase of 4 gallons of paint to cover the outside of that. Hopefully this is a good demonstration of how we take kind of the known area formulas for like rectangles and triangles and things like that and adapt them to find the area of things. You know, those ends were pentagons. They were 5-sided things, but yet we were able to kind of slice them and use a rectangle on the bottom, a triangle on top. So, and that's a good trick. That's a great trick for calculating area. We also did the subtract trick where I had the area of the whole thing and then I had a portion of that I wanted removed, and so I subtract that. It's very important when you're doing real-world applications that you're able to adapt your formulas to kind of fit the situation. Let me give you one weird example. On this campus we have a planetarium, the Hardin Planetarium, that is basically shaped as a hemisphere. And I thought about trying to get a picture of it and squirt it in there, but I'll just do this. Half a sphere, the upper half of a sphere, that's actually the shape of the Hardin Planetarium. Now, and you can check your books for this, but the area for the surface outside of the Hardin Planetarium, or for a sphere, is 4 pi r squared. And since we're doing a hemisphere, I'm just talking about this business right here, the outside curvy part. For a hemisphere, it would be half of that. And now, and the part I'm not taking into account is, okay, the circular base, that actually doesn't need to be painted. Suppose we measure the circumference of this thing at 300 feet, and the reason I say circumference is this is solid. I can't measure through it, so I have to kind of measure around it. But that's okay. The circumference, from the circumference I can calculate then the radius. 2 pi r is the circumference, the distance around the 300. So then solving for r, you get this little measure, and then I can plug that into the area formula that I talked about. Do the arithmetic, you end up with a pi squared in the denominator here that'll cancel out. It works out to be about 14,300 square feet, and if you do that same kind of calculation, it works out to be about 57.3 gallons of paint. It would take a lot of paint. I bet that's a fairly accurate measure. I didn't go measure the Hardin Planetarium, but I bet you that's pretty close to what's going on. All right, I flashed a lot of stuff by you very quickly, so let me flash up some summary pages that kind of talk about the things that I mentioned.